Hello everyone, hope you all are doing great. This is your trainer Jyotiranjan Singh from Skyy Rider Institutions welcoming you on today's session. In today's session, we'll be learning about the lithium ion batteries and its assembly with the BMS one. So all of us know that what is the lithium ion battery packs, what is the batteries, what is a cell, what is a BMS, but we don't know how to manufacture or how they are being assembled. So we'll be learning about that. So before going to the assembly part or manufacturing part, I'll be giving a brief introduction to your batteries. What is batteries? What are the type of batteries? What are the type of batteries we use electrical vehicles? What are the lithium ion battery packs? What are the types of lithium ion battery packs, and what is BMS? And we'll be looking forward some of the calculations in which will be helping us to manufacture a battery pack, and after that we'll be looking how they are been manufactured or how they are been assembled. Okay, so before starting, so let me tell you what is a battery pack. Battery pack is nothing but your combination of cells, that is means whatever the cell you will be having with you, that you can combine in a series or in a parallel connections to produce a device called as battery pack. That means a battery pack is nothing but if you combine group one or more number of cells together, and that cells will be producing some amount of power or voltage or current, and that will be in a series or in a parallel connection to produce this amount of power. So that is called your battery packs. Okay, so so what is a cell then? The cell is nothing but it is a electrochemical device that will be helping you to store electrical energy in terms of chemical energy. That means whatever electrical energy you are providing to the batteries or the cells, that will be kept in the terms of chemical energy. That we can say it is a cell. And suppose these are your cells. Okay, that is nothing but your electrochemical device that will be storing the electrical energy. If you combine it in series or in the parallel connection, this is a series connection and this is a parallel connections. Okay, so if you combine it, it will be producing some amount of power in it. So that is called as your battery packs. Okay, means if you combine it in a series or in a parallel connection, that is your a battery packs. Okay, so what are the types of batteries we are having? Generally, we have two categories of batteries, that is a primary batteries and a secondary batteries. What is primary battery? Primary battery is nothing but your use and throw types of batteries. That means you cannot recharge that batteries after they are once used. Okay, and also as soon as you install this primary type of batteries, it will be start producing the powers from it, or the power of which is kept on cells, that will be start delivering the powers to the devices you have applied, such like your remotes, or you can say your non-rechargeable watches, okay, or analog old watches you are using. That are the type of primary type of batteries they are using in it. That means once they are used and they will be thrown. And also the primary type of batteries are used in the devices where low power production or power uses will be there. What is secondary battery? Secondary battery is nothing but your rechargeable type of battery. You can charge your batteries frequently whenever they are fully discharged. Okay, but we know that secondary battery is having certain life cycle. After that life cycle, you cannot they will be not performing so efficiency, or you cannot recharge it. So mostly it will be working for some of the period of time. So that is why it is rechargeable. Once they are discharged, they will be recharged. And also this type of battery will be initiating or they will be delivering the powers whenever you initiate some commands to it. Okay, so this is called your secondary battery and primary type of batteries. So what are the types of batteries we generally use in our EV manufacturing or in EV vehicles? That is nothing but first is your lead acid battery, which is a chemical composition of lead and acid. That is nothing but pure lead, and your electrolyte would be H2SO4, that generally you use in your inverter devices. And why these lead acid batteries are being used? Because their productions or carrying capacities, that means the current carrying capacity or the power carrying capacity is more in lead acid batteries. And also one of the demerit of this lead acid battery is these are not like these are not in compact in size. they are bulky in nature, so mostly the weight to power ratio of your vehicle will be disturbed according to your lead acid batteries. Then your lithium ion batteries, we'll be learning about the lithium ion batteries somewhat, because this is a lithium ion batteries class, or we can say session, so we'll be learning about that. Then nickel dominated batteries, that is nickel cadmium batteries, nickel zinc batteries, and nickel metal hydride batteries. So these three types of batteries are generally used in a vehicle, but mostly vehicles are using not using this because the current or the power carrying capacity is less in this type of batteries, and these are highly pollutant into the environment. So these are the types of batteries most vehicles are not preferring, but some of the vehicles they are using this type of vehicle. Zinc air batteries, that is nothing, it is under research purpose, and these are in bulky in nature, so we cannot use this batteries. Mostly in the cars we cannot use it. Then aluminum air batteries, so a great news to our Indian people that aluminum batteries are manufactured in India, that is IOCL company is manufacturing it, and it is under testing phase, and the current carrying capacity in this type of batteries are more from our lithium ion battery packs, or the power production from aluminum air batteries will be more than our lithium ion battery packs, around 400 to 800 times it will be performing more than our lithium ion battery packs. So let's come to the lithium ion battery pack studies. So what is the lithium ion battery packs, and what are the types of lithium ion battery packs, and how the chemical we are using in our lithium ion battery packs? Nothing but in the cells, I have said you, in the cells there will be two terminals, one is positive and another is negative. So in the negative side of your lithium ion battery packs, will be having nothing, that is, we can say a layer device will be there, which is called as carbon or graphite plates. Means in the negative side or in the anode side will be having carbon or graphite plates, which will be helping us to store our lithium ions inside it. Means the layer formation will be formed over here, and you will be storing your lithium ions components here. Lithium ions molecules or ions will be kept here. Okay, in the positive side, in the cathode side, whatever the chemicals compositions you are having, like lithium ion battery packs are having lots of chemicals like lithium ion phosphate, lithium ion cobalt oxide, lithium ion manganese, nickel manganese, aluminum oxide. So these are the types of chemicals you will be using, so that chemicals will be on the cathode side itself. So, and the electrolytes to divide this anode and cathode region will be having some electrolytes. Okay, that is nothing but lithium salt organic. Okay, so these are the chemicals we'll be having in our lithium ion battery packs. Got it? So mostly nowadays all are using lithium ion phosphate batteries, because they are mostly compact in size, and mostly the specific energy and specific power of these batteries are more here. Okay, so let's discuss what are the types of batteries and what are the working principle of your battery lithium ion battery pack. So what is your lithium ion battery packs works? You can see these are your carbon and graphite plates. These black colors, these are your carbon or graphite plates. Okay, in which the molecules, these terms, okay, these are your molecules which are getting transport, and it is nothing but your lithium ions. Okay, and this side, whatever the chemicals you are having, like in the positive side, whatever the chemical like lithium ions, iron phosphate, or lithium oxide, okay, or lithium manganese. So these are the chemicals you'll be having on the positive side. So what happens when you close the loop? Okay, when you close the loop from the anode side and give your terminals a power production, or like we know that whenever your batteries will be getting the closed loop, means whenever you are attaching some devices to it, then only it will be producing the power. So here also the same thing, whenever in the batteries you are attaching something, then the battery is able to reciprocate, or the ions will be moving from one place to another. So now in the terms of discharging your battery from the anode side or from the negative side, all the lithium ion particles or negatively lithium ion particles will be moving to the positive directions or to the cathode side through the electrolytes, and the electrons, the negatively charged electrons, will be also moving to the cathode side in terms of your discharge. Means in discharge from negative to terminal. So now you can see the battery is getting discharged from the negative to positive side, all the ions are moving, and all the electrons also move. Now I put my vehicle into charging positions, and that from that charging your battery will be getting charged, and from the charging condition, from the cathode to anode, the battery the ions will be moving from cathode to anode, okay, from the positive to terminal. So this is continuously you're charging and discharging your battery packs. How the life cycle is measured? Whenever these ions will be continuously moving from anode to cathode or cathode to anode, that time what happens, your some of the lithium ions components will be getting weaker or they will be dead. So due to this, your life cycle will be hampered to your battery. So what is this process? We know that in lead acid battery we call it a redox reaction, but here in the lithium ion battery packs we call it as our incalation and deincalation. What is that incalation and incalation? Whenever the guest molecules will be coming and placed in between these carbon and graphite plates, that is called as incalation. Okay, see now the components are coming and kept inside these carbons or placed in between these carbons and graphite plates. So this is called your incalation process. Now whenever these components will be moving and placed in between this iron phosphate or lithium ions, like whatever the chemicals you are using, there it will be placed. So this is called as your deincalation. So whenever you are charging your batteries, that time incalation happens. Whenever you are discharging your batteries, that time deincalation happens. Okay, so what are the types of lithium battery packs we are having and we are using in our EV vehicles? So first is lithium cobalt oxide. That is nothing but it is a type of batteries pack or lithium ion battery pack that you are using for in your laptops or also in your mobile phones. So why they are used? Because they are of keeping high specific energies, means high specific energy is being produced in this type of batteries, and the power production is less here. What is that? The specific energy is nothing but the range factor, means how long your battery can drive the powers and like it can run. And what is the specific power? Specific power is nothing but which will be giving you the acceleration process, or you can say the speed one, okay, which will be used like in the terms of specific energy and specific power. So specific energy is nothing but which will be giving you the range or how much long your battery can run, and specific power is nothing but your acceleration of the speed or the speed of your batteries. So the lithium cobalt oxide is a type of batteries which will be giving high specific energy. That means the range factor will be more, or the battery can run for up to longer period of time. So these are mostly used in your mobile phones or in your laptops. Okay, also we know that it is having a moderate performances. The performance of this battery pack is moderate and it is been low in cost. The safety is also is concerned in our lithium ion battery packs, as well as this type of lithium ion, as well as the lifespan is also low here. Then we comes to the lithium manganese oxide. Mostly this type of batteries packs we use in our power tools, innovations like your hand drills, or we can say your grinding machines or cutting machines where you use battery operated one. There we use this type of lithium manganese oxide type of batteries. Why? Because these are moderate specific in range and moderate specific power. So means equal amount of range and power distribution there. Because for cutting anything we require speed also, as well as the energy also. That means it can run up to certain distance, and these are been low in cost. Safety factor is low, as well as the performance of the battery is also moderate, and also this like the lifespan of this battery is very too low. Okay, then we comes to the lithium ion phosphate. So these type of batteries are generally nowadays used in our electrical vehicles. So most of the companies are preferring this lithium ion battery packs because they are high specific in nature, means you can generate a high space range from this type of batteries, and also it showing us high mode like the power generation from these, or the specific power from these type of batteries more as compared to other type of batteries or lithium ion battery packs. So most of these peoples are using lithium ion phosphate. Also these are also means low in safety, means you can assure that means the safety factor in this type of batteries are highly preferred, means you can the battery packs is more safer than other types of batteries you are using, and these type of batteries are mostly used in our EV vehicles nowadays. Then we comes to the lithium nickel cobalt aluminum oxide, so or we can say NCA battery. So mostly you can say in our Tesla cars, previously our Tesla cars are using this type of battery packs or NCA battery packs. So why? Because here the range factor is moderate and high power generation is there. Means high power generation in the sense you can accelerate your vehicle to a larger RPMs. Okay, so lithium nickel cobalt aluminum oxide are used for that. Then lithium nickel manganese cobalt oxide, so this is the same type of your NCA battery or nickel cobalt aluminum oxide. So this is the same category, means high power generations and moderate range factor or specific energies, and these two types are more like safety factor is low here, means you cannot assure these batteries as a safer batteries. Then your lithium polymer batteries, so lithium and polymer batteries are also a type of batteries that you use in your phone as well as in your EV vehicles, because are also in the drones or in the robotics cars or anything you are performing, you are using these lithium polymers, because these are mostly why? Because you can resize this battery to any dimensions, means you can charge like you can have a tablet like batteries or the mobile like batteries, any shape and size you can manufacture this type of batteries. So these are mostly handy in nature and safer. Okay, so this type of battery is also used in our EV4. So here we can see lithium iron phosphate, lithium nickel cobalt aluminum oxide, lithium nickel manganese cobalt oxide, and lithium polymer. So these four types of lithium battery packs we are using in our electrical vehicles. Then what is the pros and cons of our lithium ion battery pack? So high reliability, you can rely on our lithium ion battery packs because it is showing us high efficiency and high energy distribution and high power also. High specific energy, as we discussed, every batteries that the 6 type of batteries are not in low in energy but moderate to high, means in an average, from an average level to a high level of energy we can produce from our lithium ion battery packs. Then contain no toxical like cadmium. Here no cadmium is been used, so instead of that we are using cobalt or manganese. So here no toxical metals are present. Environmental friendly, we can assure these are environmental friendly. But why environmental friendly? Because during the working of our lithium ion battery packs we are not emitting any gases or harmful gases. After the destruction of your battery packs only we are generating the or some pollution, so that is not that much great as compared to other type of batteries. Then lighter in weight, yes, because lithium ion battery packs very compact in size, very light in weight. They are been capable of, means whatever safe dimension you want to perform you can manufacture on that. Then EVs equipped with LIV batteries or lithium battery pack produce zero emissions and have high fuel economy. So you have seen also some of the batteries are showing from average battery means from average specific energies to average specific power to high specific power, means the power generation will be more here. So these are some of the lithium ion batteries pros, or we can say advantages. So what are the disadvantages when you compare to other type of batteries, or we can say fuels? So low energy density, means the energies density, producing energy density, if you compare with our IC engine vehicles, so it will be lesser here. Recharging time is time consuming, means yeah, we know that nowadays fast charging are not preferable to the vehicles. Instead of that we are using a quick charging, so maximum or minimum we can say 2 to 3 hours this type of lithium ion battery packs will be taking to fully charge. Then then high manufacturing cost, means whenever we manufacture it, it will be having a high cost because lithium ion elements are not produced in India and it has been we are importing from outside of the India. That is why high manufacturing cost. One more thing in this lithium ion battery packs, so that is, we can say it is a disadvantages of lithium ion battery packs. There is nothing but these are more sensitive in nature, means it is whenever you are using your phone, in your phone you are having lithium ion battery packs. So whenever you keep your phone in the charge, that time what happens, your battery is getting a normal temperature, it is there, and you can charge your batteries. Okay, but whenever you are putting your phone in charge and you are using it, what happens then nothing, that is your phone is getting heated up. Because your lithium ion battery packs are most not so accurate with their heat generation, means they produce lots of heat inside it. That is why lithium ion battery packs are loosely packed. Here you can see I have a lithium ion battery packs. You can see how loosely they are packed inside a aluminum foil only. They used to be get packed. Okay, so this is why no steel covering or anything that you can see other type of battery having, but these are loosely packed or lightly packed, because the heat produced inside these battery packs are more as compared to other type of batteries. So maximum of the vehicles that are catching fire nowadays due to this heat charges. So how this heat will be generated? By overworking or overcharging. Means if single battery packs will be used in the lithium ion battery pack that we are using only is capable of doing a certain limit of works. If you apply it for overworking, then it will work, but the heat will be produced more. And when you overcharge it, so some people, you know, that whenever their battery is getting drained for 10 to 15%, also like they have fully charged it to 100%, but you have discharged it to 90%, then the 10 that to complete that 10% also they are putting the charge again. So this is what happens. The heat will be produced, also the life cycle of your batteries also will be hampered. So this is why these lithium ion battery packs attached with a BMS to be monitored. Means a BMS will be attached to your lithium ion, mostly your lithium ion battery packs, to get a better conditions. Means your battery packs will be safer, your lithium ion battery packs will be safer, and it will be work perfectly if you attach a BMS to it. So what is a BMS? BMS is nothing but it is battery management system, that which will be monitoring all the process that you are going to be doing in your electrical vehicles or from your battery pack. Whatever the battery packs you will be using or lithium ion battery packs you will be using, you will be looking forward to this BMS device. Means BMS device will be helping you to keep your battery pack safe and getting irradiated from harmful effects. Means the battery packs will be safer with this BMS device. Okay, so this will be helping you. This is nothing but an electronical device which will be helping you to safeguard your battery packs. Okay, then what are the functions of the battery pack? So first is the monitoring the state of batteries pack and cell. Means what is the state, means what is state of charge, what is date of discharge, state of health, state of power, state of safety. So this all the things will be monitored by this BMS device. So what are these? We'll be learning on the other sessions where we'll be learning a brief introduction to BMS. So these are in this I'll be saying you the functions, but what are those functions, what is state of charge or date of discharge, you can look at our other videos in which we'll be saying or briefing about this BMS device. Then recharging battery by energy recovery system. What is energy recovery system? That is nothing but regenerative braking system. From regenerative braking system, whatever the power will be generated, this will be also monitored by our BMS. Then forms communication bridge between low level to high level hardware. That means whatever the devices we are having in our electrical vehicles other than our batteries, this will be forming a communication between the battery packs and that hardware device. Suppose controller, then it will be forming a communication between the controller as well as our battery packs. Then computation of data, that is nothing but whatever the data we are having in our battery packs from starting day of manufacturing, from the day of manufacturing till today, what are the data? Means how much maximum current, how much maximum voltage it has been generated, or it is been the battery pack is getting, what is the life cycle of the batteries, everything will be computed by this BMS device. Protection of battery pack, that is nothing but it will be safeguarding your battery packs if you are overcharging it or over voltage, the voltage fluctuation will be there or current fluctuation will be there, so it will be protecting your battery packs from this. Then cell optimization or battery pack balancing. So in this, each and every cell of your battery packs will be charged equally, and in a balancing way it will be charged, and in a balancing way it will be discharged. Then thermal management is nothing but whenever your cells will be getting heated off, or it will be having a low heat or a high heat from the nominal temperature, then it will be asking the coolants or everything to maintain the temperature in the battery packs or around surrounding the battery pack. So these are some of the major function of your BMS, so which will be helping you to monitor the lithium ion battery pack. So more about BMS, you can see our other videos in which we'll be describing about these functions and we'll be explaining about this function, what is these functions. Okay, so now we'll be designing our battery pack. So how it will be designed? Here our requirement is we want to design a 48 volt of battery pack which will be producing around 720 of watt to be delivered. Okay, in your devices, if you have seen any device you are attaching with the batteries, there only it will be denoted by watt, means the power it will be denoted, means whatever the power requirement to run or maximum power required to run from that batteries from the means whatever the power is required to run the device, that will be mentioned over there, like suppose 1200 or 900 or 720 or 800. So whatever the powers it will be given, you have to maintain that power and your device will be running. Okay, according to from that to how to generate that power, from the voltage and current will be producing that power. So what is voltage? Voltage is nothing but the pressure or the electric pressure inside your device, and current is nothing but that is your flow of your power that is been going to your devices. That means whenever suppose take a example, here you have a tanker here and you have a pipe connected here. Okay, and here the power you are having, suppose this is your battery. Okay, and this is your motor. Okay, and this is your wire which has been connected. So inside this you are having nothing but the power you are having. Okay, this power will be pressed by a pressure. That pressure is nothing but your voltage pressure. Voltage will be pressing out these powers to go and to give power to this motor. Okay, and the flow of this power is nothing but your current is flowing. Okay, what is the current you are flowing, and it will be delivered to the your device whatever you are attaching. So the pressure inside this tanker is called as voltage, and the power that is flowing from out of this device is called as your current. So voltage is denoted by volt or V, and current is denoted by I, or we can say unit is amps or Ah we can say. Okay. Now what happens? So how we can manufacture a battery? So in the I have said earlier, in the series, or if you connect in the series connection or in the parallel connection, then we'll be forming a battery pack. So here, what to generate this 720 of watt, what are the requirement I'll be having? I am having a lithium iron phosphate battery cell. So I have said you why all are using lithium ion phosphate cells, because these are high range factor, means high specific energy is being produced by this battery packs, is more moderate power, means average power you can generate, and these are safer in nature. So with the help of these cells, we'll be combining and we'll be getting this requirement of our, this is the requirement of our battery packs, means it should be a 48 volt and 720 watt. Okay, so from this device I'll be getting it. So this is a type of lithium iron phosphate batteries which is capable of giving me 3.2 volts, means each cell will be giving me 3.2 volt and 15 amps of current I'll be producing from this single cell. Okay, so for generating 48 volts, what is the requirement? So 48, okay, divided by 3.2, around 15 cells I'll be using to generate my power requirement. So here I'll be using 15 cells that will be combined in series connection, and I'll be producing this 48 volts. And how the power will be generated? So 48 into 15, that is nothing but 720 watt I'll be getting the power. So how it is been done? In series connection, if we come out in series connection, remember one thing, the voltage will be always been increased and the amps or in the current, okay, the current will be constant here. Okay, in the series connection, whenever you are doing any series connection, that time what happens, your voltage will be increased and your current will be constant, means here I'll be increasing my voltage, means 3.2 I'll be increasing it, and the amps, that is 15 amps, I'll be making it to a constant one. Okay, then when you comes to the parallel one, that time what happens in the parallel one, your voltage will be constant. If you are giving the cells a parallel connection, your voltage will be constant and your current will be increasing, means here 15 cells I'll be getting increasing its current, or like each cell is having 15 amps of current, so I'll be producing or increasing this current, and I'll be produce my current will be lesser here. Okay, now let's see the calculation. So series, so each cell is having 3.2 volts. Okay, so here 3.2 and 15 cells I'll be using, so that is nothing but 48 volt I'll be getting generated. Now when you comes to the power is nothing but the product of voltage and current. So and what is the current here? That is 15 amps, because 15 amps each cell is giving me. So 15 H I am getting from my cell, and 48 voltage I am getting from my 15 cells. Okay, so now what is my power generation? B is equal to I, so that is nothing but P is equal to 48 into 15. Okay, so that is 720 watt of power I am getting generated from my series connection. And if I'll connect in parallel one, so what happens? Your voltage will be constant, that is 3.2 from each cell I'll be getting it. Now my current will be increased, so 15 into 15 around 225. Okay, 225 into 3.2, the power generation. Okay, that is nothing but 720 watt. Here also 720, and here also the 720 watt I am generating. So whether you increase the voltage, keep the current constant, you will be generating the same power as compared to if you increase the voltage and keep power in a constant one, or the current will be constant one, then the power will be the same. If you are increasing the current also and keeping the voltage constant, then also your power will be the same. So at last we require the power which will be driving our vehicle, not voltage and current. Voltage and current you can fluctuate, or you can give in any other connections. Okay, you can give a series connection as well as a parallel one. So but at last we require a power to run our devices. Okay, now I'll be arranging, now we'll be seeing about the parts. So how we'll be arranging it and how we'll be doing it. So we'll be doing in the series connection, means we'll be arranging all my 15 cells in a series one, and I'll be giving a series connection to it. Then I'll be attaching the BMS to it, and my power requirement will be, my voltage requirement will be 48 volts and 728 of watt I'll be generating from that. So let's see how it happens. So each cell is having 3.2 voltage in it, and having around 15 H in this H of current in it. So we'll be connecting in the series connection. So how are we going to connect? We'll be seeing it. So what else we require? We require this type of battery holders, in which we'll be going to put our battery cells for proper connections. Then we require a BMS device which will be monitoring our each and every cells, how it will be connected. I'll be showing you. Then this is a jumper wires in which we will be connecting our cells to the BMS. Battery strippers, or we can say battery stripers, which will be helping you to connect it in the series connections. Then we'll be having one ammeter for checking our currents, one connector, the final connector, in which will be going to provide the output of power from output or input to the battery cell. It will be better if you have a spot welding machines with you, so that it will be very easy for you to connect the batteries. But as maximum people will be not having the spot welding, so here we are using the soldering iron. So how we are going to put the soldering irons on that, and how and for soldering purpose we require fillers and fluxes. So we'll be using that too for our connecting the battery packs. So the first process is that we'll be bringing these holders, and it will be connecting in the sides. Okay, means we'll be connected in a series. So here I have 15 cells, so in the base I'll be having 15 rows. So like this, here the holders will be like this, it will be fitted. So So 6 is unconnected, then the final is 8. Okay, so in this I will be putting it in the series connection. So how to put it in the series connection? Let's see. So here I have one cell. I don't know which one is the positive and which one is the negative cell. So here how I can check it? Through the help of my voltmeter, or we can say multimeter. So this is the red one is the positive probe and the black one is the negative probe. So here I will be connecting, like here you can see the battery cell is having both the ends. So one end will be, I will be connecting with the one probe, and the second one I will be connecting with the downward. Okay, so here you can see, so like this I will putting. So here you can see it is coming on the positive side, means here no negative side is coming. If I will be reversing it, see, if I will be reversing it, then it is coming on the a negative mark is showing. That means it is negative, means my positive side is in the negative side. So I here came to the conclusion is this is my positive side and this is my negative side. So like this I will be checking for all the cells and I will be connecting. So previously I checked all the sides and I marked which one is positive and which one is negative. So like this I will be connecting. So here first I will be keeping it to the positive side. So here I will be putting the positive side here. Then the very next cell I will be connecting within the negative side, means I will be keeping with the negative side on. Okay, means this is the positive, this is the negative. Then here also I will be putting an negative battery cells. So here another cells I will be putting in the negative side. Here again the positive one, means alternatively I will be keeping one negative, one positive. Okay, so this is the positive one. This is again I will be keeping it as a negative. Again this is the positive. This is negative. Then this is positive. This side cell negative, positive, negative. Okay. Here I have connected around 4, 8, 12 batteries. Another 3 batteries I will be connecting here, because according to the calculation for making a 48 volts of battery, so 3.2 into 15 cells you will be connecting, then we will be getting around 48 volts. So here I will be connecting 15 cells in it. So here one again positive one I will be connecting, here one negative one I will be putting it. So here also I required another holder to be connected. So this one will connect. So now here anywhere you can keep the positive. Okay, this side or maybe this side you can put the positive. So for you can see this is loosely packed now. So here in the top also I have some fuse connector which will be again mounted on it. So like this I can connect it. In a quick process we will be connecting it. This battery is connected here. Here, like these connections, you have to make it so that it will be easy. here let's check some of this. So here it is prepared, my total connections set is required. Only you have to connect it. This is not having any like this. You have to put it. Be careful with this because it's the electronic part, and you know that lithium ion battery packs are so sensitive. So you have to be very much careful with while manufacturing it or while doing it, assembling it. So these all the things I have set it. Okay. Now I require a soft magnet so that I can tight it properly. Each and every cell I have to tight it properly. Okay. So as I said you, if you have a spot welding machine, then it will be very much easy. But maximum people will be not having the spot welding machine, so they'll be having the soldering machine. So here you'll be using the soldering machines to make the connections between these cells. Okay, so how we'll be connecting? So first is from here we will start the connections. From here I'll be keeping the batteries. My batteries on means here I will start the connections. So the strip here I have showed you. So I'll be cutting the strips here like in with these small pieces so that I can connect it here. Okay, so like this I'll be connecting it here. So in a series connections, each and every cells I have to give the connections. Okay, so this is the rough map that we are going to connect. Okay, so this is the rough map. In this side we'll be connecting it like this only. Okay, so in the opposite side also the same process, means opposite side if you want to connect. So if this side is getting wet, so here you will be connecting. So like this you have to connect. So like this. Here is the positive side will be empty. Okay. So like this you have to connect. So this is the entire road map of your back side and front side of your battery. So how will be connecting it? Let's see. So I will be removing it all. I am making it aside. Now starting from this side. Okay. So here you have to connect it. It will be better if you have a spot welding, and it will be easy. Okay, after that, keep the plates above it and try to heat up so that the liquids will stick to it properly. Below the materials will be melted and it will be stick out properly. So yeah. So if it is not going, then add some materials below it. Add some materials below it so that the materials will be heated up and it will be connected. Sanjay, clip होता है clip down होता है clip बढ़िया clip अरे बढ़िया okay, so as this is stuck here also we have to put some materials so that we can put then you can put it here in these edges. Okay. In this edges you can put it. Okay, as it is connected, you have to connect it in the same way in all other sets. So, in a quick way, we will be seeing it. First, you have to deposit the materials, then you have to connect it. So again,
that the downside material will be getting done properly. Then hard materials available. Okay, like this, hard, align it properly. Then hold the device so that you won't get heat sense on your hand. So it is getting heated up. So here you have to hold it the device. So here, like these things, you have to perfectly do it. And just here a bit you have to put it on the edges. This part is if you're putting it on the edges, then it will be good. Just start properly. Now it is been done. The same way in every directions here like this. One connection here, another cell means series connection you have to do. So here another one, here this one, here again these two, then these two, these two, these two, like this. This will be empty here. Okay, this part will be empty here. So because this will be my positive, which will be giving me output. Okay, means it will be connected directly to the system that you are using. Even vehicles, if you are using it directly, it will be from here. This part, your positive direction or positive line will be going. So here again the same way. If possible, cut it a bit softer. A bit softer. On the edges, yeah. on this side also. Okay, like this you have to connect it. So again, same way. So now your top part is ready now. Okay, the top part is ready now. Now we'll be connecting in the bottom part. In the bottom part will be the top part. You can see here I have connected in the one series, means one cell it will be performing. Here the second cell, here the third, fourth, and fifth, sixth. Okay. So this cell I have kept empty because from this cell the direct positive connection will be going out, when you'll be connecting it to the BMS, from BMS with the help of this circuit or this connector, it will be going out. Okay, in the positive side. So in the bottom side, so again the same thing with the help of our the strippers, or where strips we will be connecting these cells. First we will be connecting this. Okay, we will be starting it from here. बैटरी चेक करो, बैटरी आउटपुट चेक, बैटरी आउटपुट चेक. So in this way, you have to connect it to the batteries. Okay. And another one. This line is completed. And be careful while you are applying the filler materials, because if the filler material touching one of your cells, then it maybe get sparks or short circuited. So be careful while you are using the filler materials. Okay. In this way also. This way also you have to. Now this way also. And be careful with your filler materials. Shake it properly. Is down on that. It's very good. Then the last one, you have to keep it here, and this will be the negative side of your battery packs. Means from here, the negative side of your connections will be going on. So before this is the last connection, you have to connect it. Connect it properly. So our total battery pack is now ready. Now you can connect directly a wire or output connections from these cells, or as it is a lithium ion battery pack, so we will be attaching our BMS on it. Okay, how to attach that BMS? So let's see.
Okay, so now your total battery pack is ready. Means here you can give a negative and positive terminal, and you can use this battery pack. But as we have discussed, the lithium ion battery packs are more sensitive, so it is monitored by a device called as BMS or battery management system. BMS or battery management system. So what is the work of this BMS? We have explained you earlier also, or you can check our other videos like in our basic electrical vehicle classes, in which we have explained about the BMS and what is the work of BMS, how it is working. So all the things we have explained there. So this device we are going to connect in the battery pack. So you can see here again I have to attach that BMS, we have some jumper wires. Okay, these are called the jumper wires, in which one circuit is been present, which will be giving or which will be attached to this BMS devices. Okay, like this it will be attached. So here we have 16 wires. Okay, means 16 wires will be connected in these battery systems. Here everywhere will be connected. So 16 wire, how? Because one is positive and second the last one will be positive. The last one of the device will be positive, and this will be the negative one. Means this black wire will be going to connect in the negative side of your battery pack. And how we are going to connect it? If you are connected the positive or negative side here in the reverse directions, in the reverse side, the very next wire or the second wire you have to connect it in the reverse side. Means here you have to connect it. Okay, so like this alternatively we will be connecting it. So means if you are connected the first wire here, means the black wire here the second wire you have to connect it. Okay, here in the second wire you have to connect it. Then similarly the third wire here and the fourth wire here. Okay, so like this alternatively, fifth wire here, sixth wire here, seventh wire here, eighth wire here, ninth wire here, 10th wire in the bottom side. Okay, like this you have to alternately connect it. See it here, and I'll be putting it the material. So before that I'll be applying some of the materials here or the fillers. So this is the positive one. Okay, connecting it at the positive side. Okay, so here I have connected the positive one, negative one. So on the reverse side of it, okay, on the reverse side of it, beside the black wire, okay, there is another red wire. Okay, this one, the second wire beside the black wire. So these you can see here, this is the second wire I am taking. So these I'll be keeping on the alternative side of our negative side. Okay, so here I am here, so the second wire will be connecting here. Okay, because this is the positive side. Okay, negative side I have kept the black wire, so this is the second wire I have to keep it. So before that,
Okay, then the third wire, again we have to put it here. Okay, so from the jumper wire we will be collecting the third wire. So this is the third wire. Okay, so this is the third wire which I will be putting it here. Okay, then the fourth wire will be here. Okay, fourth wire. So from here I am collecting the fourth wire which will be kept this side. Okay, this is the fourth wire. Now the fifth wire will be here. This is the fifth wire which will be connected here. Then the sixth will be on the bottom reverse side. So this is the sixth wire which I will be connecting here. Then seventh reverse side, seventh will be here. Seventh will be here. Let me arrange it properly. It will be messy, looking like messy, but this is the process we have to follow. Okay, the seventh one So this is a 3, 3. This is the 7th one. Okay. So which are we going to connect it here? The 7th is connected here. The 8th will be connected here. Device, the device 3, 4, 5, 6, 7. Now I think 8th one is this one. So 8th one will be connected here. Okay, 8th one is connected here. Then turn it. Then similarly the 10th one on the reverse side. Here we will be connecting the 10th one. Okay. Then 11 on the reverse side. Here 11 will be here. Okay, this is 11th is done now. Then 12, 13, 14, 15, last is 16. Okay, so 12 will be here again. So this is how you have to do alternatively, and you have to remember the sequence too. So you have to remember the sequence too, so that the blender will, and you have to more be focused in it, so that the blenders will be not done from your side. There will be no you have to be focused, because it is an electronic item. Then 13, then will be this. Second 14, 14, 14, then here it is 15 1 will be connecting, 15 1 will be connecting here, starting from black to red. Okay, okay, then the last where you have to put it is in the positive side of your battery pack. So this is your positive side, I have said it. So this is the positive side, here we have to put it. Okay, positive side I have. Okay, so like this, your all the jumper wire been fitted. Okay, so now your BMS is ready. Means all the jumper wires has been connected here. So now it's time to check the voltage of this cell. Like we'll be checking it in the series way. Like each cell is showing me exact amount of voltage or not, so that we can find the errors. Okay, so here I have connected everything. So now I'll be finding the voltage. So I have my ammeter here, which I'll be keeping it in the top so that you can see the voltage. So in this way it will look okay if you can see. Okay, it will show you the nice direction. So here one my black probe. Okay, my black probe I will be taking it in the negative side of my battery, and on the opposite I will be showing it that in the negative side this one. Okay, this one I will be putting in the positive side. So see, it is showing me 3. Okay, then this probe I will be bringing to the connections here. Okay, so it is showing me 6 because it is in series connection. So here I will check it in this. Okay, these two combination I will check. Okay, then here again I will be checking it for 9 approx. Okay, this 12, you can see 12 it is showing. This is 15 it will be coming. Okay, then this is, you can see 18. So up to this is 21. Okay, so in the bottom one 24, in the this side 27, this side 31, this side 35, 34, 35 it will be coming. So this side 37, 36, this side 40, 41 approx, and this side 43, 44 it will be coming, and this side 56 or 47 around it will be coming. So you will be saying, sir, you have said that it will be coming around 48. So because the battery is not fully charged, okay, so after connecting we will be charging the battery, then it will be showing this. So now after taking all the batteries, after this we will be connecting the BMS device. Okay, so this is my BMS device. It is a lithium iron phosphate 15 cell 48 volt BMS device. Okay, what it will be doing, I have said you, it will be monitoring our systems or our battery pack. So this device, okay, this device, here we have two terminals. One is B1, another is P1. B1 is battery minus. That means it will be connected on the negative side of your battery. That means where the black wire is coming. Okay, means here it will be getting connected. Okay, this blue wire will be connected here. Okay, connected here directly, and this blue wire will be connected here. And you'll be asking, sir, what about the positive side? Where the positive side will be coming? Here it will be directly going to the from positive side. You can connect a direct wire to the connector itself. The red wire you can connect it. So let's see. So first we'll be putting the blue wire here. Okay, in the this side. So we'll be putting the blue wire. Okay, it's the black. So you have to hold it tightly because these are the silicon wires. This will be getting more heat. Okay, so you have to be morely, and it will be taking lots of time to be connected. Okay. So first we have added some materials upon it so that it will be stick properly. Hold it properly. Add some filler material. Okay. Now let me add some filler materials. Turn it. Okay, so like this you have to connect the B minus on your negative side of your device. Now now we'll be connecting a wire, external wire in the here we'll be connecting an external wire so that it will be directly going and connected to the connector itself. Okay, because connector will be too short here, so we'll be connecting some additional wires in it. So here I have some additional wires. So here I will cutting here I can connect it. So we're trying it. Here it's directly I will be getting connection to it, so that it will be very help, like it will be very much sticky. Okay. So here filler material will be putting first. So lots of filler materials will be required here. So here keep it all the filler materials. So lots of filler material you have to keep it here. Okay, and this wire you have to connect it. Okay, with a coupler I am connecting it because it will be very much effective. So it will be taking some time, but you have to keep patience on it. Directly where also you can connect it, where you can connect it, but like where it will be taking lots of time to get connected. So here in this way I can connect it. So connect it perfectly, so you have to add some materials to it. Okay, so this is also possible, you can do it. Okay, so like this you can keep it, and here your almost your soldering will be over, and here you can connect it directly to the connector. So this is the positive side. Okay, so this is the positive side. You have to cut it a bit. Sir, 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 Siddhan sir, Siddhan sir, Siddhan sir, Siddhan sir, sir, sir. Black paper. Okay, here you can cut it a bit, the strippers. Okay, so this is the positive side, so you have to connect with the positive side. Let me bring, this. So this you have to remove, and here this like it will be connected directly to the this connector. Red connector means red wire, it will be directly getting connected, and this black wire will be connected from the BMS itself. Okay, from here it will be getting connected. Okay, so before that, okay. To make it big, you can connect another wire. Okay, to make it big, you can connect another wire. From here, you can connect. From this coupler, you can connect it. This coupler. And before that, let me cut one end of this coupler. Okay. So, again, okay. Now you can connect it. You can directly cut this coupler and put it, but as this is silicon wire, it will not getting so much strength. So with the help of this, here I can connect it and apply black tape here. So here I have my black tapes. Okay, and here putting this, I can connect it. So here I can put the soldering screw, but here I am not putting here directly. I am putting this black tape. Okay. Then it will be extra strong. and it will not getting short circuited easily. So this is connected now. Okay, so this is connected, and here from this connector I'll be cutting it. Okay. So here. So also this side I will cut. This is cut. Okay. Now my both the end is ready. Now this is the positive side. So positive here. This will return the red wire always be positive. So I'll be connecting. Okay. So this is a technique, you can use it, divide it by 2, this is also divided by 2, then attach this one like this, one end, okay, and attach this one, okay. Now what happens, you can connect it roughly, you can tie it, okay, this roughly you can tie it. And on the bottom apply the black tapes here, okay, apply the black tape here, and it will be strong enough. Now or you can give the heatsink tube also, you can put it. Heatsink tube will be more preferable as compared to black tapes. Okay, this is how you can connect it. Okay, so this is your positive side is ready now. So negative side is this one. So same thing you have to do, divide it by 2. This is also divided by 2. Connect it here. Okay, another end. Okay, now both the things you can combine it and connect it. Okay, the device is now almost ready. With this connection part, you have to put it in black tape. So now almost your battery pack is ready. Almost your battery pack is ready now. So here, this is the output or input. You can charge it from here, or you can discharge the batteries from here also. Just check it, and now you have to connect. You can see here is the connections. So here this the bearings the jumper wires you have connected. Here you have to put it in this. Okay. Now your BMS or your battery pack is fully ready. Okay. So now you can just now you can check the voltage of your battery packs. So BMS is connected now. So this is the output or input. You can put the charge or discharge from the batteries from here by giving the connections. So here in the positive side, I will put in the positive probe, and the negative side, the negative probe. So my voltage is 46.8 now. My battery pack is proper now and my battery pack is fully manufactured. Now what I'll be doing? I'll be doing packing of it. So in the next videos, we'll be seeing how to loosely pack these battery packs. How to loosely pack these battery packs we'll be seeing in the next videos. Okay.
Now we are ready with our battery pack, and it is we can use it in our vehicle. Before that, we'll be just packing this battery pack with our heatsink tubes, and we'll be loosely packing it because, as I said, it is been heat generated from the lithium ion battery pack is more. So here we'll be using a heatsink tube to pack it, and in the next video we'll be seeing it how it has been packed and how it has been kept in charge, and also we'll be seeing it after keeping it fully charged. Then we'll be using it in the vehicles. So till then, for such type of videos or for such type of knowledge things, you can join Skyy Rider Institutions, in which we'll be going to learn n number of devices that you are using in your EV vehicles as well as in other sector of your engineering. Also, you can join our YouTube channels, or you can join through our social media channels that will be helping you to grow in your own efforts. So till then, keep learning, keep growing, and thank you.